Good morning, dear friends. Today we are going to see a topic called as carbohydrates, and these carbohydrates have been extensively studied from a long period of time, but still in your syllabus, it's a part of syllabus, and so we will be learning today the method of carbohydrates, or what are the carbohydrates. So let us understand one by one in that sense. So what are carbohydrates? Carbohydrates seems to be compounds that are tremendous biological importance. Why they are said to be so much important? Why it is put in our syllabus? That we need to discuss a bit. So for that purpose, they serve as a form of stored chemical energy. It is a very rich source of energy, basically chemical energy. Why? Because in terms of carbohydrates itself, carbohydrates means ultimately they are in a form of energy only, and that energy can be provided to the cell or to the total body. So therefore they serve as a form of stored chemical energy. They provide energy through oxidation. Oxidation reaction takes place, and therefore through oxidation they generate energy. They supply carbon for the synthesis of cell components. So every cell need to respire or need to perform their function, and for that purpose they need energy. So this energy can be given, or from where the cell would get the energy? The cell would get the energy from this carbohydrate. So it is the supply of carbon through synthesis of cellular compounds. They form part of the structure of some of the cells in the tissues. So ultimately these cells, they aggregate itself to form a tissue, and for their aggregation they need a substance called as carbohydrate. So carbohydrate has been extensively utilized. Carbohydrates are polyhydroxy aldehydes or ketones or substances that yield such compounds on hydrolysis. Carbohydrates have the empirical formula CH2ON. So this N will be in that particular position, which may change as according to the carbohydrate or as according to the sugar moiety. So therefore CH2ON, this is a very general formula that has been employed for carbohydrates. Now there are three main classes of carbohydrates. One is called as monosaccharides, which contain a single polyhydroxy aldehyde or ketone unit, that is saccharose, and in Greek sugar, that is glucose and fructose. So sugar, whenever we are dealing with terms of sugar or chemical compound, every time that sugar is said to be a carbohydrate. So what are these examples of monosaccharide? Glucose and fructose are said to be the examples of monosaccharides. So monosaccharides, if you come to across, then glucose and fructose will be monosaccharides. Disaccharides consist of two monosaccharide units linked together by a covalent bond. For example, sucrose. See this. Two units are joined with the help of linkages. Basically the covalent bond linkage has been happening over there, and because of that linkage, one would certainly get the two moieties of sugar molecules attached with this. Oligosaccharide contains from 3 to 10 monosaccharide units. For example, raffinose, 1, 2, 3, 4. More than 3 if we consider, then it is said to be oligosaccharide. So oligosaccharide are those which are attached to each other in that sense. Polysaccharide, it contains a very long chain of hundreds of thousands of monosaccharide units, which may be either in straight or a branch chain. See this, polysaccharide. Branch chain, many of them are there, it may be thousands of monosaccharide molecules attached to each other. Then we say it is polysaccharide. Example is cellulose, glycogen and starch. So these are the main four classes. What are those? Monosaccharides, disaccharides, oligosaccharides and polysaccharides. Polysaccharides are of two types based on the function and composition. Based on the function, polysaccharide two types: storage polysaccharide, starch, and structural polysaccharide. See this. This is an excellent diagram which signifies this. What are the basic components of classification of carbohydrates? We have seen monosaccharide, disaccharide, oligosaccharide, polysaccharide. Monosaccharide consists of glucose, fructose, galactose. Disaccharide, sucrose, lactose, maltose. Oligosaccharide examples are raffinose and stachelose. While polysaccharide, starch, glycogen and cellulose. You can see this single unit, one sugar unit, 2 to 10 sugar units, and ultimately 10 or more sugar units, it will be considered as polysaccharide. So this chart will define us what are the different classification of carbohydrates. Stereochemistry of carbohydrates. Stereomoles. So this may be asked in the exam. What are the stereomoles? Stereomoles, glysaccharide, the simplest carbohydrate, exists in two isomeric form. They are called as mirror image of each other. See this. L-glyceraldehyde and D-glyceraldehyde. See this. The mirror image, exactly. If you see the carbon position, this hydrogen molecules and its OH molecules, just the mirror position. If you see this from this angle, it is changed in this angle, and then you can see, or then you can say that this is the isomer or stereoisomer of each other, L and D. Okay, this is L and D, and what are these? These are conformations. So based on that conformations, these are same the mirror image, and therefore they are called as stereoisomers. These forms are stereoisomers of each other. Glyceraldehyde is a chiral molecule. It cannot be superimposed or its mirror image. The two mirror image forms of glyceraldehydes are enantiomers of each other. Enantiomers of each other. You directly cannot place them on top of each other. Therefore, they are called as enantiomers. Chiral carbon. Chiral molecules have the same relationship to each other. Left hand and right hand, when you reflect it in terminal, a chiral object can be superimposed on the mirror image. Means such a kind of thing is there, but when it imposed in this fashion, either it will move in right direction or it will move in the left directions. A chiral objects can be superimposed on the mirror image. Any carbon atom which is connected to the four different groups will be chiral and will have two non-superimposable mirror images. It is a chiral carbon or a center of chirality. So that will be called as chiral carbon. Molecules are enantiomers of each other, have exactly the same physical properties. Enantiomers जो भी है उसकी properties कैसे रहेंगी? It will be very similar to each other. For example, melting point, boiling point, index of refractions, but not their interaction with polarized light. Polarized light vibrates only in one plane. It results from passing light through a polarized filter. See this. Polarized light, how it works out can be shown in this particular diagram. Optical activity. These are all properties of carbohydrates. So, levorotatory substances rotates polarized light to the left. For example, one glucose, and this is minus glucose. The dextrorotatory positive substance rotates polarized to the right. So, D-glucose. This is L-glucose and this is levorotatory and dextrorotatory. So, what I told you earlier also, L-glyceraldehyde and D-glyceraldehyde, those are all levorotatory, and this is also the dextrorotatory. Molecules which rotate the plane of polarized lights are optically active. Most biologically important molecules are chiral and hence are optically active. Often living system contains only one of all the possible stereochemical forms of a compound. In some cases, one form of a molecule is beneficial and the enantiomer is poison, for example, thilimon. So, if the conformation changes takes place in the molecule, then it will be poisonous molecule. Fischer projection formula. Fischer projections are convenient way to represent mirror images in two dimensions. Place the carbonyl group of 1 near the top and the last achiral CH2OH group at the bottom. See this. In a very simple sense, if you go in this fashion only, then the mirror images can be superimposed. Naming. When there is more than one chiral center in a carbohydrate, look at the chiral carbon farthest from the carbonyl group. If the hydroxyl group points to the right, when the carbonyl is up, point to the right, it is called as D-isomer. See this. If this OH group comes to on the right hand side, then it will be D-erythrose. Correct? And when the hydroxyl carbon points to the left, it is called as delta. So look at the hydroxyl carbon. See here, hydroxyl carbon is on the right, therefore it is D-rotatory. If it is on the left hand side, then it is N-erythrose. Correct? So this is the part that we have covered up today, that is carbohydrates, and the basic structure of carbohydrate we have seen in this particular topic. In my next lecture, we will always deal with some other properties of carbohydrates. Thank you.